Today we're doing 8.3 in the Green Book. It's solving linear equations using linear combinations. Homework is page 371, and we are doing 1 through 36 odd. New vocabulary is the elimination method or the addition method. It means the same thing, a linear combination, and we will be using the multiplication and addition property of equality. All right, so solving a system of linear equations, this time using the linear combinations or the elimination method. So really quickly, let's review what we've looked at. We've solved a system. Remember, to solve a system is to find the intersecting point. We've solved a system by graphing. Okay, this is time consuming and it's not always accurate. We've solved by substitution, where we get one variable alone and then we substitute to solve for the other. Right? Now we're going to be using what's called elimination. I don't think you have to really write about it, but we're going to add both equations up and down. So A plus C is equal to B plus D. There you go. So let's begin. So you have two equations. What we're looking for here is actually two variables that are opposite, that look alike but are opposite. See these two? Oops, they're supposed to circle the Y too. They look alike, but they're actually opposites. You know, one's positive and the other's negative. So we're going to add these equations up and down vertically. Okay? So I'm going to draw a line underneath the two of them. Just like you're adding, we're going to add everything up and down. So the x's together would make 5x, right? The y's will cancel out, and 6 plus 4 will equal 10. So 2x plus 3x makes 5x. The y's cancel, positive y, negative y. They're additive inverses. And 6 plus 4 is 10. And now I'm going to divide both sides by 4. And I get x equals 2. I use that 2. And then I'm going to substitute it in. So now I'm doing 2 times 2x plus 4. Substituting it in for the x. I get 4 plus y equals 6. Subtract 4. And we've solved for y. So our solution is 2, 2. Now, you should always, this is the easiest thing you can do to check. So if I substitute in a 2 times 2 here, right, 2 times 2 plus 2. Does that equal 6? That works. That's 4 plus 2 is 6. 3 times 2 minus 2. That equals 4. So the point works for both. So that is, I found a good answer. My answer is accurate. Okay? All right, so now you try the next one. Go. Now let's check our work. As I add up and down, we notice that the x's are additive inverses, so they cancel. And I get 4y's equals 8. Divide both sides by 4, and y equals 2. Now, as I substitute in, x plus 3 times 2 equals 5. X plus 3 times 2 equals 5 is x plus 6 equals 5. And then we subtract 6 from both sides. X is equal to negative 1. So my ordered pair, now the big part to remember is that you place it accurately. Remember, this is our x and our y. So it's gonna, sorry, I was about to sneeze. So So I have negative 1 comma 2. And we have to check it. Negative 1 comma 2. So if x is negative 1, I could have negative 1 plus 3 times 2 is 6, right? 3 times 2 is 6. So negative 1 and 6 makes 5. That works. Okay, so if this is a negative 1, it would be a positive 1, right? And 2, that makes 3. It works. So be checking yourself mentally or write it down. Just, that's not the work that you show, because this is the work you show. I don't want you to show me a guess and check for your work. All right, so now it's a little bit different. The first two problems were in standard form. Okay, one here is in slope-intercept, the other is in standard. We need to get our equations into into standard form, where x and y are on the same side. So we can line up our x and y. So with this, we're going to have to subtract 3x first. Okay, we'll have to take this equation, subtract 3x. Now I'm going to line the other one up right underneath. I've got 2x minus y equals 5. Now we can solve using the elimination method. So I'm going to draw my line. Notice once we do negative 3x plus 2x, that makes negative x. My y's cross cancel, and I get equals 9. Now remember, we can't leave a variable with a negative, so that's really positive x. I'm going to multiply everything by negative 1, and I get positive x equals negative 9. Okay? So if x equals negative 9, I can go to either original equation. I'm going to go to the y equals. I think that will be easier. I'm going to substitute in negative 9. And there I have negative 27 plus 4. It's 23. Negative 23. So my ordered pair is negative 9 comma 23. Okay? Negative 9 comma negative 23. Sorry. All right. This situation's a little bit different because there's nothing that will negate each other. So we have to manipulate the equation so it does, one or both. So in order to make these become opposite, I think I could multiply the bottom equation by negative 2. If I do that, then our x's will become additive inverses, and that's what I'm looking for, opposites. Positive 2x, negative 2x. So I'm going to multiply the whole bottom equation. Now look at how I'm writing this. Okay, I'm going to put parentheses. Oh, well, you'll see we can't negate anything, so that's not the way to do it. Right, you'd think we do this, but there's nothing to negate, so we didn't eliminate a variable. So we're going to multiply the whole bottom equation, and then I want you to put an arrow to what it becomes. Negative 2 times x, and write it under the next. I want you to put lay your work out like this. Don't put it beneath in this case. If you're going to manipulate an equation, put an arrow to the right. Negative 2 times x is negative 2x. This shows the reader what you want, where you want their eyes to go. Negative 2 times negative 4y is negative 8y, positive 8y. Negative 2 times 9 is negative 18. Now I'm ready to subtract. Vertically. Positive 2x, negative 2x, they're additive inverses, they cancel. 3y and 8y make 11y, and negative 4 and negative 18 make negative 22. Divide both sides by 11, and y equals negative 2. Now I get to go back to either original equation. I'm going to take the second one. It looks a little easier. And I get y equals 4 times negative 2. equals 9. So x plus 8 equals 9. And now I'm subtracting an 8. X is equal to 1. Okay, so x equals 1 comma negative 2. Alright, so let's try one on your end. Let's see where we're at. And you should always be checking. So 1 minus 4 times negative 2. 1 minus 4 times negative 2, that makes positive 8. That equals 9. And 2 times 1 is 2. And 3 times negative 2 is negative 6. So 2 minus 6 equals negative 4. All right, now you try it. Pause the recording. Now let's check our work. I have to multiply the bottom equation by 5. All terms. I say get 10x minus 5y equals 35. I'm going to subtract, so I'm doing the addition method or elimination to eliminate. So it's a positive 2 and a positive 10 make positive 12x. My 5's cancel, and here I'm left with 45. 12x equals, divide both sides by 12. Now, all I want you to do is reduce it. 3 goes into both, 15 times 4. Keep it as a reduced improper. It's going to be easier to do that. Go to either original equation. I always like the one with less. All right, so I end up with 30 over 4 minus y equals 7. I could turn this into a fraction and do it as a fraction problem, or multiply by 4 and just get rid of. What do you want to do? Let's clear it. Let's multiply everything by 4. Then I'm left with 30 minus 4y equals 28. Subtract 30. Negative 4y equals negative 2, divide by negative 4, divide by negative 4, and y equals 1 over 2. So it's 15 over 4, comma, 1 over 2. Show me you can work in fractions. Okay? Let's see what we got. What did I get? Did I get negative or positive? Yeah. So that was my 1/2. And then you can convert it or leave it in reduced improper. It's a point, it's not a slope, so if you wanted to change it, it'd be okay, but you know me, I'm okay with 15 over 4. Less work. All right, the last type of problem is the most difficult, okay? And that is where you're going to have to manipulate both equations so that you can get yourself an additive inverse. So we can either do something so that we can cancel the x's or the y's. I think I'd probably multiply something to, let's see what my power, to get rid of the y's. So I might multiply the whole first sentence by 2. That way I get a 6y. And the whole second sentence by 3. That way I get a negative 6y. Since they're already opposites, I think I'd multiply. Oh, they're doing the opposite. They're eliminating. I'll show you the other way too. They're eliminating the x's. So they're multiplying by 5. So I get negative 10x, right? That becomes negative 10x plus 15y. Remember, everything gets multiplied by 5 equals 25. And the other one is 2 times 5x would be negative 10x, positive 10x, minus 4y equals 8. Look at how I show my arrows and show the new equation. Do not put it underneath. It's hard for me to find out if you're doing it right. Put it to the right and arrow over. Now, we end up with 11y equals 33. Divide both sides. And y equals 3. If I had eliminated the other, it would have looked like this. It should have been 3. So if I had multiplied everything here by 2, that would have worked too. The difference here, and this by 3, is that we would have been eliminating these, because it would have gone to positive 6y and negative 6y. Okay. All right, so we have our y. And now I'm going to use that in either original equation and solve for the x. So 5x minus 6 equals 4. 5x equals 10. Divide both sides by 5, and x equals 2. Okay, so my solution is 2, 3. You should check it in both. Does 2 times 2 is negative 4. 3 times 3 is 9. Does that equal? Yes. I'm going to try the next one. Times 2, that's 10. Times 3 minus 6 is 4. It works. So that was the most complicated kind, where we actually have to manipulate both equations. We're multiplying by a common number so that we can either eliminate the x's or eliminate the y's. Okay, so 2 and 5, the closest multiple is 10 that they both divide into. So we're multiplying them by 5 and by 2. I'm going to go back really quick. Here, hopefully with the elimination method, we always look for something that naturally has an additive inverse. So let's go back to the start really quick. Okay, so right away, first thing we did was we saw naturally that there was an additive inverse with the x's. So we eliminated them. The next level was to get them both in standard form. We had to move the equation around so that we could use the elimination method or addition method. And there we have the y's being eliminated. And then we have this next level of difficulty was manipulating one of the equations so it could be the additive inverse. So multiplying the whole bottom equation by negative 2 so the x's would cancel. Right? If we change it, notice we put our arrows to the right. And then the biggest level of difficulty was manipulating both equations because there's just no additive inverse. So the first equation I'm multiplying by 5. The next equation I'm multiplying by 2. It makes the x become negative 10x and positive 10x. And we're done. Okay. There we go. And that's our lesson.